Have you ever been in a meeting where a manager makes a big claim and your gut tells you something's off? Well, how do you actually test that claim quickly without needing a PhD in statistics? Today, we're diving into a super simple but really powerful test that top consultants use to cut through the noise and make decisions based on actual data. So here's our game plan. First, we'll cover what this thing even is. Then, we'll talk about when to pull it out of your toolkit. After that, I'm going to walk you through the exact 6 steps to get it done. We'll apply it all to a real-world story from a bank, and then we'll deliver the final data-backed verdict. Let's jump in. I mean, seriously, how can you test a major business claim with literally just a plus or a minus sign? It sounds way too simple to be a real statistical test, right? But that's exactly why it's so elegant and so powerful. Okay, section 1. Let's break down what the one sample sign test really is. So, the official definition calls it a non-parametric test. All that fancy term means is that this test is built for the real world. It doesn't need your data to be perfect, like a neat little bell curve. Its one job, its only job, is to check if the median, that's the true middle number in your data, is what someone claims it is. The easiest way to think about this is like a statistical coin flip. Imagine you have a number somebody claims is the middle. If they're right, you'd expect about half your data to be higher and half to be lower, right? Kind of like flipping a coin and expecting roughly half heads and half tails. This test just tells us if the results are so lopsided that it's probably not just random chance. Now, like any good tool, you have to know when to use it. This isn't for every single situation, but when it fits, it's perfect. So let's look at the right conditions to deploy the sign test. This test is your best friend when you're dealing with messy, real-world data. You know, the kind that's skewed one way or the other, not that perfect bell curve you see in textbooks. As long as you've got a random sample and the measurements don't influence each other, you're good to go. It's absolutely brilliant for things like figuring out if customers prefer product A over B, or, like we're about to see, putting a manager's claim under the microscope. All right, let's get into the how-to. This is the core playbook. There is a foolproof 6-step process here, and if you follow it, you'll get a defensible, data-driven answer every single time. You see, the process is just pure logic. First, you state the 2 competing stories, the claim and what you think is really going on. Then, you set your standard of proof. That's your significance level. Step 3 is the easy part, just assigning those pluses and minuses. 4 and 5 are where you crunch a couple of simple numbers. And finally, step 6, you compare those numbers and you make the call. Theory is one thing, but let's make this real. We're going to take that 6-step process and apply it to a situation at a bank, where a clerk on the front lines decided to check if their manager's claim actually held up to scrutiny. So here's the setup. The branch manager states, as a fact, that the median number of new savings customers they get is 64 a day. In our world, this is what we call the null hypothesis. It's the status quo, the claim that we are putting on trial. But a clerk who's actually there opening the accounts has a hunch. It feels busier than that. They suspect the median is actually higher. This suspicion? That's our alternative hypothesis. So to figure out who's right, they collect data from 10 random days. The stage is set. And here is the magic of the test in action. It's so simple, it's beautiful. For each day, we just ask, was the number of customers more or less than the manager's claim of 64? If it was higher, like 72, it gets a plus. If it was lower, like 60, it gets a minus. That's it. We've just turned a list of numbers into a simple score, 8 pluses and 2 minuses. Okay, so now we get our test statistic. And with a small sample like this, the rule couldn't be easier. It's just the smaller of the 2 counts. We had 8 pluses and 2 minuses, so the smaller number is 2. That's our test statistic. Just remember that number, 2. And right here, this is where most people get tripped up. This is the classic battle between your gut feeling and statistical proof. Your brain is probably shouting, wait a second, 8 out of 10 days were higher? That's 80%. Case closed. The clerk was right. And look, that makes total sense. But here's the multi-million-dollar question. Is that result actually meaningful? Or could it have been just a random lucky streak? This is the moment of truth. The math gives us something called a p-value. The best way to think of a p-value is as the fluke factor. It's the probability we'd see results this lopsided even if the manager was right. Now, before we started, we set our bar for proof, our significance level, at 0.05. That's a pretty standard bar. The fluke factor for our data came out to be 0.055. So here's the simple rule. To prove your case, your fluke factor, the p-value, has to be less than the bar you set.
But our fluke factor, 0.055, is just a tiny bit greater than our bar of 0.05. It was so close. But in the world of statistics, close doesn't count. It means the evidence, while interesting, just isn't strong enough to meet our standard of proof.
So, we've run the numbers, we've compared them to our standard. What's the final verdict here? What do we tell the manager and the clerk? And the verdict is this: we fail to reject the manager's claim. Now, listen to that wording very carefully. We're not saying the manager is definitely right. We're saying that the clerk didn't bring enough evidence in this 10-day sample to prove the manager is wrong. The original claim stands, not because it's been proven true, but because it hasn't been proven false.
So, what are the big takeaways here? First, the sign test is a quick, back-of-the-napkin way to challenge a claim about a median. It's incredibly handy. Second, it's a workhorse. It's designed for the messy, skewed data we see every day. But the most important lesson is the third one. Your gut can point you in the right direction, but it can also be misleading. Seeing 8 out of 10 feels like a slam dunk, but statistical rigor gives you the clarity to know for sure.
Now you have this incredibly simple tool in your back pocket. So it leaves me with one final question for you to think about. What claims are being made in your world right now that everyone just accepts as true? And what hidden story, what crucial insight might be waiting to be discovered with just a simple plus or a minus sign?